Welcome to my class of computer graphics. Today we will learn about DDA line drawing algorithm. Line drawing algorithm is a graphical algorithm which is used to represent the line segment on discrete graphical media, that is printer and pixel based media. Line drawing algorithm is a graphical algorithm because whenever a line is drawn on the screen, it is visible. The effect of the algorithm is visible on screen. So it is referred to as graphical algorithm. Also, it is based on the coordinate system. A line contains 2 points. The point is an important element of a line because by joining points, we form a line. So let us study the required properties of any line drawing algorithm. An algorithm should be precise. That means each and every step of algorithm must be adequately defined. Each steps must be self-explanatory and clear. Fitness. An algorithm must contain finiteness. It means the algorithm stops after the execution of all the steps. It means the algorithm complete after a certain time. Easy to understand. An algorithm must help learners to understand the solution in a more natural way. How the algorithm work, that concept must be clear to the learner. Correctness. An algorithm must be in the correct manner. That is, whenever a line needs to be drawn between 2 points, the algorithm should ensure that all the points are illuminated over the screen. Effectiveness. The steps of an algorithm must be valid and efficient. Uniqueness. All steps of an algorithm should be clearly and uniquely defined, and the result should be based on the given input. What is the input or what is considered as input in a line drawing algorithm? 2 points coordinate will be given. One is the starting point of the line and another is the ending point of the line. By joining these 2 coordinate, x and y coordinate, a line is drawn. Input. A good algorithm must accept at least one or more input, and an algorithm must generate at least one output. It is important to understand that an algorithm, line drawing algorithm, must generate the desired output. Only those pixels should be drawn which are falling under the coordinate of the line from starting to end point. Only those coordinates will be illuminated. So these are some of the required properties of algorithm. Now let us see what is DDA algorithm. We must note down the steps of the DDA algorithm. We need to write that a line connects 2 points. So it is considered as a basic element in graphics. It is considered as the basic element in graphic. So to draw a line, what is needed? To draw a line, we need 2 points We need 2 points between which we can draw the algorithms. So what should be the point? Like if I say x0, y0 and x0, y0 is the starting coordinate of the lines. So x0 and y0 and x1 comma y1. So these are the two screen coordinates, the starting point and end point of the line. Now let us write the DDA algorithm. DDA algorithm will also called digital differential analyzer. Digital differential analyzer. And this algorithm is considered as it is a simple line generation algorithm. It is simple line generation algorithm. This is considered a simple line generation algorithm explained explained step by step. So we will look into the different steps. What is step 1? If we look into step 1, get the input of two endpoints. Get the input of two endpoints. What are the endpoints? These endpoints are x0, y0, and as we have already said, it's x1, y1. So these are the starting point and end point of the line. Okay. Between these 2 points, that means the line will start from x1, y1 and will end at, the line will start at x0, y0 and it will end at x1, y1. Now let us look at step 2. What is step 2? Here we calculate the difference between two endpoints. So difference between two endpoints. Two endpoints means starting point and ending point. The difference is calculated. Difference is represented as x1 minus x0, and similarly here the difference is calculated as y1 minus y0. Why it is dx and dy? Dx is the x coordinate and dy stands for the difference in y coordinate. So this is the difference between x coordinate and y coordinate. We have to find out. First we will take the input as the two endpoints of the line x0, y0 and x1, y1, and then step 2, that if dx is x0, y0 and dy is y1 minus y0. Now we will look at step 3. What is step 3? Let me look at step 3. If we go to step C, after finding out the difference, what we need to do? Step 3 is based on the calculated based on the calculated difference in step 2, since the step 2 calculates the difference. So based on the calculated difference in step 2, we need to identify the number of steps, steps to put pixel. To put pixel means what are the number of steps for lighting a pixel that is required. Now we will compare if dx is greater than dy, if dx is greater than dy, then more steps dx dy we have already explained. This is the difference in x coordinate and difference in y coordinates. If dx is greater than dy, if dx is smaller than dy, then coordinate, otherwise in y coordinate. So this is the third step. Now if we write it in the form of algorithm, we should make absolute value of dx then absolute d of y dx and dy is the difference as already explained in step 1. So if absolute value of dx is greater than dy, then steps is equal to absolute dx and steps is equal to absolute dx, else absolute dy. Okay, so this is the difference. That means we have to calculate whether it is dx and dy, and if absolute dx is greater than absolute dy, then we will take into consideration, or more number of steps is put for absolute dx or else absolute dy. Now what is step 4? This is step 3. Now if we look into step 4, step 4 is calculate the increment in x coordinate. Increment in x coordinate means the progress in x coordinate. Calculate the increment in x coordinate. Similarly, in y coordinate also. Now, how to calculate? We calculate it as x increment is equal to dx by, we typecast it by float, dx steps. This is the value of x increment. Similar thing we will write for y increment. Sorry. Similar thing we will write in the case of y increment also. Like y increment is equal to dy floats steps. Now we will go to step 5. What is step 5? If we look into it, step 5 is put the pixel by successfully incrementing x and y coordinate accordingly and complete the drawing of the line. Now we write it as for integer, we will take an integer variable. We will initialize the integer variable with 0. Here it is steps. What is steps? We have already explained in step 3. We will increment it as this is the, okay. So x is equal to x plus x increment, y is equal to y plus y increment. So in this way the algorithm will proceed. X is equal to x plus x increment. X increment, how the x increment and y increment is calculated, that is being written here. Now based on the incremental value of x and y, we use put pixel round x round y. Put pixel means this is the function used for drawing the point or illuminating the point in screen. So this is the algorithm of line drawing. This is known as DDA line drawing algorithm. There are different line drawing algorithms available in computer graphics. This one is one type. Next, we will study in another class, that will be Bressenheim algorithm. So there are different algorithms for line drawing. What are the advantages of DDA line drawing algorithm? It is the simplest algorithm and it doesn't require special skill for implementation. It is a faster method for calculating pixel positions than the direct use of the equation used for line. What is the equation for drawing line? It is y is equal to mx plus c. This is the equation for line generation. Floating point arithmetic in DDA algorithm is little bit time consuming. Look here, it is floating point algorithm. So here it takes floating point under consideration. So it is little bit time consuming. And the algorithm is orientation dependent. So this we can say these are the characteristics feature of DDA algorithm. Now that's all for today's class. We will learn about another type of algorithm in next class. Thank you for watching.